Good morning, everybody. Hey, Jason. Good to see you. Got my cup of coffee right here, and it's called Queen Blend, and freshly ground this morning. So, anyway, getting back to the Bedini and the Trigger Coil, we had one heck of rain last night here in Irving. Had 70-mile-an-hour winds, and so I've been cleaning up the brush that blew down from the trees, and it's been a day. Anyway, we've got a new subscriber that came to the channel. Name of him is Self Power of Things, and interesting work that he's doing with coupling generators. And so love these as Roy St. Vincent, Vinny St. Vincent, his channel, YouTube channel, says that, love these garage physicists. And so everybody's working hard on different things. Just to kind of give you our main topic that we're going to end up with at the end of this discussion is going to be the trigger circuit and the inductive trigger circuit. I'll have a little bit better presentation if I can find my old wheel. I use these 27-gallon totes for a lot of my stuff, and I buy those at Home Depot. Highly recommend them. They're the right size, and they can go outside. They pressure wash off real well. They keep the contents dry, and so I highly recommend that. I also recommend going to Harbor Freight and buying the little furniture dollies, and you can stack those 4 high and label them and keep those through, because you end up collecting a lot of stuff if you're messing with this, and you start working with different technologies and putting things together. But the show notes that I have for the day is the neon 120 volt transistor protector, and then jumper wires, and type jumper wires I use. Kind of wanted to go over the colors and what they mean in electricity. Being a boat mechanic, one of the things that I loved finally that they got a wiring harness system to where you knew what went to where. For instance, gray was always the tachometer line. And so I just kind of want to, I'm not going to touch on the boat side of it, but the colors nowadays, we do have a standardization in colors. And so if you're wiring, it's good to know that. And it also helps your mind, also building your projects and demonstration where people have an idea of what's going on. I touched briefly on like this lead I made right here. I made it just out of telephone wire, bell wire. And I put a red lead on the end of it, and because that particular energy that's coming from that has more potential positive energy, and the yellow means that I've got a pulsating line, which depending on where you ground it is still pulse DC, but keep those things in mind when you're demonstrating your product. I want to talk, basically just touch the basis on inverters and things that you run across with. The batteries, when you're going with solar power, when you're going with emergency backup, is the most expensive part of the system. And so I will be building my own batteries, and I've done tests, and they'll be nickel batteries. I love the idea of the self-run generation system where you don't have that, but I'm going to be exploring all technologies and trying to improve designs on inverters, chargers, and wall warts. And I want to basically touch also on diodes and the 2N4001 diode. The voltage is actually rated for is 100 volts. Now, one of the problems is if you talk to people that worked with semiconductors back in the old days, and a lot of these semiconductors are really old, okay? And they've been packed up for a long time. They were manufactured a long time ago. So that what that actually means is that it has to be tested. And on the Bedini circuit between the emitter and the base, it's recommended to put a 4001, 2N4001 fast switching diode in there. And the reason is because they wanted to get that kickback voltage through that at 100 volts. The thing is, they made them up and then they would test them, and they would test the minimum. So if they had one that would handle 1,000 volts, that was their minimum specification. So a lot of times with your semiconductors, they weren't interested in this type of energy. They were trying to stop the parametric open system. And the truth is that you're setting the environment up as a pump. They called it the ether back in the day, and it's just like a well pump. You know, in electricity operates pretty much just like a pumping system. And so once you understand that you can have semiconductors that are rated, like I said, the 4001 as opposed to the 4007. The 4007 is rated for 1,000 volts, okay? And so that's the reason on the charging system, they don't want a kickback coming anything over 1,000. The Bedini system is capable, under the right conditions, of delivering 800 volt pulses that are really hard to see unless you have an oscilloscope, but it's actually happening, circuit wise. And so the neon bulb can prove that actually on that charging system, and it'll make once it makes that arc, which is about 80 volts, that propagates that, you can see it. So we want to touch a little bit on capacitors, especially the polarized capacitors, and give you a little bit more example for what this is. This capacitor is a 33 UF, which UF is microfarad, and the capability of that is to deliver a pulse potential and of about 1.57 amps. Okay, so even something that small can give you a hell of a jolt, especially if it's charged up to 400 volts. Okay, so you got 400 volts that'll charge up to, and it can deliver the equivalent of 1.57 in a burst. And when I was demonstrating the pulse charger off the capacitor, off the AC mains, that's what I was wanting to prove, that side of it. Now, ultimately, we charge not a dead 109 amp hour, and that's something else. Battery ratings. In the marine industry, we have kind of a combination crank deep cycle. Okay, and when you read the ratings on them, they should pull. If you have a fresh, good condition battery, no dead cells, no weak cells, they should deliver 1 amp of current, okay, for 109 hours, okay? And they will do that if they're in really good shape. Depending on the battery, performance, that rating will be less. So, but they're really not the right type batteries for emergency mains backup. Uninterruptible power supply service, lead acid batteries in the 12-volt range just aren't the monkey. The golf cart batteries, the 6-volt systems, and it all works out to be the same thing because you can put them in parallel and you can put them in series. And I'm going to get into more managing systems as I get into the solar side, the wind side, the main side, and what I'm doing with that. Just basically wanted to touch on that in the inductive coupler. So anyway, grab you a cup of coffee and settle in, and appreciate Jason, appreciate you being here, my friend, and look forward to talking to you on the telephone. I sent you an email with my telephone number, and feel free to call me anytime. If I don't answer the phone, I'm either asleep for a minute or running boat motor or pressure washer motors, or can't get to the phone right then, but I'll respond back to you. I always try to respond back to the guys that are working with this energy. And if I have anything that you think I can answer, I'm available to you. And like I said, I'm not trying to make any money. I'm not trying to sell anything. Just trying to get people to duplicate what I found. And, it's kind of like a step of faith. Faith begets faith. And faith is just simply things that are unseen. So being a flight instructor, I demonstrate how to, take off and land, and people say, well, he does it all the time. I guess he's a pretty good flight instructor. But that's the way I learned. I learned from model airplanes, and then got to fly the real thing. And I told that story later on. And as we did the maneuvers and spins and spin awareness and working under the hood with the IFR work, faith begets faith. And so you learn what's going on from somebody that's done it before. And so I do my best to impart those knowledge keys to that. I was figuring out the other day how many hours of a syllabus, and I will ultimately write a syllabus to teach this. I've compiled many syllabuses working with the best of the best people. If y'all want to be a part of that, really want a syllabus to learn this energy and to present it correctly. The reason I'm not right on top of a professional syllabus because I hadn't written it yet. And syllabus is just a railroad track, and it gives you all the pieces when you get there, you understand what you're doing. And so this is kind of a dry run, putting the syllabus together, just as I'm working on things. One of the things in adult education, and it's really with children too, and kids and adolescents and whatever, you have to teach at the time that they're interested in what you're working with. And that's one of the things with the internet, YouTube videos. You can go back and look at those things and get confidence in your person that's your instructor or leader. I'm not a leader. I'm just a guy doing stuff and sharing what I'm doing. And I enjoy it. It's really fun. So today we're going to get into the transistor, and there's two types of transistors. There's the NPN and PNP. Okay, and the basic transistor base is the 2222 that everybody uses. Now, I'm not going to tell you exactly which transistor. It's a little bit better than the 2222 as far as performance, but I've worked with the 2222s as well. And the thing that needs to be explored with the transistor is the amplification that you can get. And so, you know, you can get a 1 to 3 amplification, 1 to 10 amplification. There's all kinds of amplifiers right on up to 1,000. I'm going to lightly touch on the Darlington towards the end of this, and that's the paired transistors, and some transistors come as paired set. And so I know that kind of gets basic, but you know, my hope is that as people find this channel, find out what it's about, and get into it, and take the time to listen to where they'll have a background of how that's set up. So you look at the Darlington configurations, you know, study how those are made. Well, yesterday I had this side already prepared, okay, and I went ahead and I drew the circuit for this side, and I'm showing an ultimate configuration charging batteries, and I've explained the demarcation line, that your volts are your run side, your amps are your charge side, and it gets confusing because the run is connected to your trigger, okay, and it's connected by inductive forces. Now, once you train your coils, that coil develops memory. You can get them to resonate pretty quickly once you understand this without an inductor in it. In other words, a hollow core. And you can also drive motors with that. And a lot of people had never seen that demonstrated. And it's still the same energy in, same energy out. What got me interested in that part of the technology is a Russian physicist. And I'm probably going to really screw his name up, but Terrell Campanidis. And he is the first physicist that I've ever saw that demonstrated solid state resonating coils. Then, of course, I found Floyd Sweet, and he did the same thing. And it's a system that pumps energy from the ground. Terrell took an old radiator and buried it and put a big ground cable on it. And the another thing that I want to talk about is ground potentials between ground rods that are several feet apart, and you have basically a battery in plain sight. And just most people don't recognize it as that. And when you start looking around and realizing what the grid is, that number 6 line that comes down every telephone pole, and at the bottom they just simply wrap a coil up and go down about 4 or 5 feet, and that ground is a huge part of the system within that. Now you'll notice up here on my emitter line, that's the negative line that's going to the run side, I have it disconnected, okay? And the reason that I have it disconnected is because I use alligator clips from that point to my first battery, and I always start my system out at 12 volts, okay? But do I really just have 12 volts there? And the answer is no. You actually have a potential because of the setup just on that first battery of 24 volts. So a lot of times you'll hear me in my past videos, do I have 12 volts or do I have 24 volts? And so if you're running just 2 batteries, you've actually got 24 volts of potential within the system, okay? And what's so slick about this circuit is kind of a combination jewel thief circuit, common jewel thief circuit, but that's your jumper point. And so when I hook up you always hook the charge side up first, okay? and you can do it with one battery. Okay, I'm just showing them in parallel there, because in parallel, if each one of these batteries is 100 amp hour and you got 5 of them, the beauty of the system is that you've got 500 amp hours. Okay, so in other words, 1 amp on a really good battery system, you know, up to potential, 1 amp will run for 500 hours. That's a long time. Okay, and that's what they're designed for. You know, about 20% of what they are. Another thing is not running these down when you use lead acid batteries. The charging circuit on commercial chargers, they start beeping at you when their voltage drops to about 11.5 volts and completely shut off at 11.2 volts. So your run times on those type chargers that have the, inverters that have the protection in it, is not going to be too swift, because you're not running that battery all the way down. You're just running it from 11.2. Most time with your resting circuit, you know, when I see a good battery that's resting, and it's rested over a period of time and it settles at 12.8 volts, when you put a load, depending on what the load is, that may, on a deep cycle battery, go to, you know, 12.4 almost immediately. Okay, even just with a 1 amp load on it, but it should hold that 1 amp load, you know, for about 100 hours. Okay, the most boat lighting, yacht lighting, in the old days used incandescent, and we always shot for a 1 amp load for the whole system, and so an emergency type situation, but we didn't have any voltage limiter. We would run it, you know, basically on down to 6-7 volts, where that bulb was burning dimly, and that's the situation with 109 amp 109 amp hour battery, is that they were designed to run way past those things, but they, you know, basically just pulling 1 amp. So that's some explanation that you have in the difference of who's designing that system and what they're thinking. Okay, so you're in there, you know, if you have an emergency power and you only have one battery and you're using an inverter and that sucker is kicking off at 11.2 volts, then you put another battery in parallel on that, and you're going to run both those batteries down pretty quickly. So the wanted to explain that side of it. So we got to the run circuit yesterday, where we just stopped here at the collector. Right here is the collector's point coming off the final run of your coil, and so you just grab that, and that terminates right there. And again, you can do that with alligator clips to that. This diode right here is the 2N40007. The diode right here is recommended to use the 2N001, okay, or 001. So fast capacitor, because they really wanted that 100 volt kickback on there, but you have to actually test it. You know, there's a testing procedure to get that done to see if you actually have a diode like that. But that's actually in the original circuit designed that way. And then I told you the story on that. Okay. 3 watt, 12 volt lamp there. And that basically tells you when you energize. Now, when you hook up your battery system, that light comes on instantly. You're already resonating. You got to shorten the circuit. That light shouldn't come on until you do your first spin of the motor. Okay, And then also your protected neon bulb shouldn't come on until you hit your first couple of pulses of the system. It's done off the pulse of the magnet running by the inductor and picking that up. Did a demonstration on the sweeper, and this middle right here is the sweep, okay? And so when you have it configured like that, when you turn it all the way to clockwise, that should be the least resistance, okay? And then as you pass that resistance on up with the 75 ohm, I use a 5-watt resistor there. When you pass that on up, you're actually balancing the system, which makes it resonate faster, and it changes the voltage balance between your charge set and your run set, okay? And the DAF man always showed that these two were shorted right there on that side. And I've always just left it open because in the Bifilar system, and I'll show that configuration, I hook my kickback coil side, and there's a specific way I do that, and I've showed the kickback effect. So just wanted to clarify that just a little bit. And then that comes to the final trigger. That's the final trigger at the top. To be run there. So your final run comes up to the collector, and that's your termination. And then man, I can't spell. I'm a great engineer, but I'm not a good speller. I can check my own mistakes. Okay. And again, I use a jumper wire from this to the emitter. So this line right here, comes over here, little jump, goes to the emitter. Okay. And the emitter on the 22222 is the ground side. Okay. And then you can do your jump right there on the trigger. So what actually happens is you're creating a path to ground. And another slick trick is after the system, you see how that's right there? You can also put one more jumper right there. And so do you have 12 volts, 24, or 36 volt capability when you're just using 3 of those batteries right there, okay? So leave your comments and check that out. But basically, we know that we can charge batteries one from another and gain input. Now, what happens is this first battery on the run side, it takes the hit. That's where most of the voltage comes through. So you can actually take this battery, move it to this slot, and just keep going through there. And I've made it run for months and months and months, never touched a wall wart, just by keeping that. So just understand electricity wants to find its course, and you always have a battery in the system when it's configured that you have to rotate in the system, but you can rotate it, keep it charged and discharged, and it's really good for ultimate run time to run them up and down. And I used to run them to dead zero. I used to run them out. So that's basically the basic Bedini schoolgirl type setup, and then other modifications that you can make to find your parametric resonance. For this type energy, I really recommend having a heat meter. Okay, check your coil temperatures. I run coils at 130 degrees, no problem. Okay, run transistors without a heat sink in 130 degrees, no problem. Okay, so but when you start getting over 130 degrees and you're climbing, you got to start watching. So a normal warm temperature is about 130 degrees with the type circuit I just showed you. Again, I haven't used the 50 ohm, but I've used the 75 ohm. I kind of split the difference, but I've on up to 330. When you start doing the Darlington transistor setup and delivering that, I'll show you why that's there and the voltage potentials off the resistor. But I use a 5-watt resistor, 75 ohm, and recommend having a lot if you're dealing with this type. Resistor run about 130 degrees in the system on a normal Bedini system. The protection circuit, that's one of the best protectors I found. That's a neon bulb in there. They're rated at 120 volt, and the real small neon bulbs. This is one of the larger ones, but you want enough gap there. If they're too close together, they won't bleed off enough energy voltage up past the amperage through and knock out your. So the real tiny neons I found not to be good. The larger size neons, 120 volt, were very good for this technology. I will put a plug in for a company that's north of where I live. It's up towards Carrollton, Tanner Electric. Electronics, Tanner Electronics. And Mr. Tanner's been there for a very long time, and you can buy everything from Arduino to the newer stuff from Tanner Electric. And I'm sure he'd appreciate your business. He has a lot of the old tubes that you can get. I mean, he don't have them on display, but a lot of the stuff I'm restoring tube units. I've been able to get tubes through the years from Mr. Tanner. The 3-watt bulb, and I run this bulb up to 48 volts on my run side all the time, no problem. And for short times, I've run higher voltages. But all this is the 3-watt induction. There, my kitty, that's Angel Cakes. That's a Norwegian forest cat, and she is just precious. And so you notice that I have a lot of alligator clips that are on the wire. Again, I've shown the demonstration with the potentiometer, and when you twist it, if you're looking at it and you twist it all the way to that side, this is a sweeper. And right now there's no resistance between those. Okay, now this one is 1,000 ohms. Okay, so if I turn that resistor clockwise and get 100 ohms resistant here, this other side off this neutral is going to be 900 ohms. Okay, so if I go to 20%, that's going to be 200 ohms. This side's going to be 800 ohms. And a little bit more, off the neutral, this side is going to be 300 ohms, and this side will be 700 ohms. You get the idea? And this will be 400 ohms, and off the neutral, this side will be 600 ohms. 50-50 right in the middle. Off the sweeper, your 50 ohms. I use that for my kickback voltage on that, and I'll explain it more on my coil that I've explained in other videos. I have one coil, one layer that just runs from one side to the other. It just goes one layer across it, and I haven't counted how many I did. I did not wind this lens. I just took it and hand wound it. Used a tree in the backyard to keep my tension on, and had my wife keep them close together, and I just kept twisting until I got there. It took a little bit, maybe 15, 20 minutes to wind it that way, but it's a tightly wound coil. I checked it for shorts and everything. And anyway, I intend to send that back through the system on this sweeper over here. And then, like I said, this is a trifilar system. I'm going to use the green steel wire as the inductor, as the trigger. And then the other two, going to show the pulse width modulation to develop this on in to demonstrate a three-phase unit that's actually in phase. Okay, and simple to do, but it's pulse width modulation is what's going on with that. So you have so many things going on with the Bedini. This is a little 3-amp charger, and it's based on the same technology that this is. Okay, so it's a 110 volt system. So basically, if you take 21 microfarad, multiply it times 3. I haven't been inside this unit, but I've used it in the so you can calculate very quickly what size capacitor to expect to find should you open one of these up. Found it on sale for about $12, I think, at Walmart, and so I bought one. They have a bigger one too, and in some cases, when if it calls for over amperage, it has codes for how it codes, and you need to have a bigger one as well. But for it's smart technology, battery type tender, based on this technology right here that I've shown you. One of the meters that I really think you appreciate is the kilowatt hour meter, and you've seen that demonstration of why and how I use that. This is kind of an unusual light bulb, and I'm going to read on what it says. This is a 150 watt light bulb. I knew by what it was drawing it was over 100 watts, and at one time I thought it was a 200. I just didn't read it. But that's 150 watt, and it has the plugs right on the side of it. A lot of times I'll slowly discharge a battery just by hooking the leads to this line to run that battery down before I charge it up. And there's not much heat that comes off of it, but it does get warm on that. And, basically you're just using that tungsten in resistance as the drain to drain the battery down slowly, and that works very well. Again, this resistor, another thing that was there, and I just happened to buy them both at the same time, and I have all kinds of these from different boats and stuff that I've used, and I wanted to see what's out there, and the cutoff voltage on this is 11.2 volts, so operates fine between a range of 13 volts and 11, but when it starts squealing, it goes off, and it'll take and show the demonstration on the inverter. So, and this is not a pure sine wave inverter. There are this is a cheap one, but just kind of bought it, see how it would perform emergency power. It had to be modified on the voltage for me to do what I was doing if I was going to use it for emergency backup. It does have the USB ports to charge your cell phones, and so if you have a good hot battery, especially off a car or something like that, then you do have capability. Of course, most cars nowadays have these built-in cigarette lighters and everything else, but just wanted to see what that was. This is not recommended to run at 100% power. So, basically it's good for 200 watts. It shows 25% on that 150 watt, but it'll really run a battery down pretty quick, especially if it's not a new hot battery. I found this test light, I believe, at Northern Tool, and this has been one of the best test lights for finding if I have AC potential, if I have DC. It's a great little test light. I use it on boats all the time, and then I have other equipment that I use on boats that's more expensive. I don't have it here at the shop, but but basically for trouble test light to go through a circuit, this shows your ground potential. It shows you your hot potential. If you have DC pulsing current, it shows that. If you have AC current, you have that. And it's got a wide range of use. I wish I knew the model number. I wish there was more on it. And like I said, I found it at Northern Tool on sale for like $2, and I got it, and then I haven't seen any more of this particular test light, but that's been a excellent test light for a lot of things. So just kind of showing you the basic tools to get when you start off, where I've been buying them from. These little cheap 7-function meters, they're basically throwaway. You can find them on sale for $1.99 at Harbor Freight, and pretty good little meter, only 5 amp. Acclimate. The test leads, after you use them over a period of time, they fall off, and so you might have to solder some alligator clips and other things on it, but I highly recommend. Now, for the same type meter, I believe this came from Walmart, and this has a 10 amp fuse protection on your amperage side. Remember that when you slide that up there, you have a direct short between these two lines, okay? And so it gets a little confusing, but when you're hooking up for the amperage side, all you're doing is completing that circuit with a meter reading that's in there. So right now, if I were to hook this to an AC circuit in this configuration, that's a dead short. I'd get, if I took that lead and put it into the unit there, it would be there. I've got to end this video. I got to get to work, and hope that helps you. Hope you understand that. And we'll see you next time. Y'all have a great day. And if you're not having fun, you ought to be. It's a great day. See y'all next time. Bye.